Tonight, we are going to travel slowly through one of the most fascinating mysteries in the history of space exploration. A quiet question that scientists, historians, and dreamers have asked for decades. Why did humanity stop going to the moon for more than 50 years? To understand this mystery, we need to gently return to the 1960s. A time when space was not only a place of curiosity and exploration, but also a stage for one of the most intense rivalries in human history. The world was divided between two powerful nations, the United States and the Soviet Union. This rivalry became known as the Cold War, and one of its most dramatic arenas was space. At that time, every rocket launch carried not just astronauts or satellites, but also pride, ambition, and political power. Each country wanted to prove that its technology, science, and people were the most advanced on Earth. And so began what historians now call the space race. The Soviet Union achieved many of the first major milestones. In 1957, they launched the first artificial satellite, Sputnik 1. The small metallic sphere orbited Earth and sent simple radio signals back to the planet. Yet its impact was enormous. Suddenly, humanity realized that space was not just a distant dream. It was reachable. Just a few years later, the Soviet Union achieved another historic milestone when Yuri Gagarin became the first human to travel into space. In April of 1961, his spacecraft completed one orbit around Earth. The entire flight lasted only 108 minutes, but those minutes changed history forever. For the United States, these achievements created a powerful sense of urgency. American leaders understood that space exploration had become deeply connected with technological leadership and global influence. So in 1961, the President of the United States, John F. Kennedy, made one of the most famous announcements in the history of science. He declared that before the end of the decade, the United States would land a human on the moon and return them safely to Earth. At the time, this goal seemed almost impossible. Human beings had barely learned how to survive in orbit around Earth. Rockets were still unreliable. Computers were primitive compared to even the simplest modern smartphone. Many engineers were not even sure whether astronauts could safely walk on the moon's surface. Some scientists feared the lunar soil might behave like deep powder, swallowing spacecraft entirely. Others worried about extreme temperature differences, radiation, and the unknown dangers of the lunar environment. But despite these uncertainties, thousands of engineers, scientists, technicians, and astronauts began working together on one of the most ambitious projects humanity had ever attempted. This effort became known as the legendary Apollo program. The scale of the program was extraordinary. At its peak, more than 400,000 people were involved in building the rockets, computers, navigation systems, life support equipment, and spacecraft required to reach the moon. Entire factories were built to produce the enormous rocket that would carry astronauts beyond Earth's gravity. That rocket became known as the Saturn V. Even today, decades later, it remains one of the most powerful rockets ever successfully flown. Standing over 110 meters tall, the Saturn V was taller than a 30-story building. When its engines ignited, the ground trembled for kilometers around the launch site. The rocket burned thousands of tons of fuel in just minutes, producing a thunderous roar that could be heard miles away. Slowly, gracefully, it would rise from the launch pad, carrying 3 astronauts on a journey nearly 400,000 kilometers through space toward the moon. But before astronauts could land on the moon, NASA needed to solve hundreds of complex challenges. Engineers had to design spacecraft capable of traveling through the vacuum of space for days. Astronauts would need oxygen, water, temperature control, and protection from radiation. Navigation was another enormous challenge. The spacecraft would have to travel across vast distances and arrive precisely at the moon's orbit. Even a tiny miscalculation could cause the spacecraft to miss the moon entirely. Yet step by step, mission by mission, the technology improved. Early missions tested spacecraft systems in Earth orbit. Later missions traveled around the moon without landing. Each flight provided valuable data that moved humanity closer to the ultimate goal. Then finally, in July of 1969, the world watched as the mission known as Apollo 11 began its historic journey. Millions of people across the planet gathered around televisions and radios. Families stayed awake late into the night. Schools paused lessons so students could watch history unfold. After several days of travel, the spacecraft entered orbit around the moon. 2 astronauts prepared to descend to the surface in a small lunar lander known as Eagle. Those astronauts were Neil Armstrong and Buzz Aldrin. As the lander slowly approached the lunar surface, computers began issuing warning signals. The landing area was filled with large rocks and craters. Fuel was running dangerously low. Yet calmly and carefully, Armstrong guided the spacecraft to a safe landing site. When the engines finally stopped, a quiet message was transmitted back to Earth. The Eagle has landed. A few hours later, Neil Armstrong climbed down the ladder and stepped onto the surface of the moon. With that step, humanity became a species capable of walking on another world. For the first time in history, footprints appeared in lunar dust that had remained untouched for billions of years. But this incredible moment was only the beginning of the story. Because in the years that followed, astronauts would return to the moon again and again, exploring its landscape, driving across its surface, and bringing back samples that would change our understanding of the solar system. And yet, despite these successes, something unexpected happened. Only a few years later, humanity stopped going to the moon entirely. For more than 50 years, no astronaut returned. The question is why? And the answer is far more complicated than most people imagine. In the years following the historic landing of Apollo 11, humanity continued its careful exploration of the lunar surface. The first landing had proven that reaching the moon was possible. But scientists still had many questions. What exactly was the moon made of? How did it form? And what secrets might be hidden beneath its quiet, gray surface? Just a few months after Apollo 11, another mission began preparing for launch. This mission was known as Apollo 12. While the first landing had been a demonstration that humans could reach the moon, Apollo 12 had a slightly different goal. Astronauts would attempt a precision landing near a robotic spacecraft that had been sent to the moon years earlier. That robotic spacecraft was called Surveyor 3. Scientists wanted to see how the harsh lunar environment had affected equipment that had been sitting on the surface for several years. The astronauts landed successfully and even walked to the Surveyor probe, carefully removing parts of the machine to bring back to Earth for study. It was a remarkable moment. Humans were not just visiting the moon, they were beginning to conduct detailed scientific research there. As the Apollo missions continued, the confidence of engineers and astronauts grew. Each new mission carried better equipment and more ambitious goals. The astronauts were no longer simply stepping onto the moon, they were exploring it. One of the most exciting missions came a few years later with Apollo 15. For the first time, astronauts brought a small electric vehicle to the moon. This vehicle, known as the Lunar Roving Vehicle, allowed astronauts to travel much farther from the landing site. Instead of slowly walking short distances, they could drive across the dusty landscape, exploring craters, hills, and ancient geological formations. The moon, once seen as a quiet and unchanging world, began revealing a surprisingly complex history. Astronauts discovered rocks that had formed billions of years ago. Some samples suggested that the moon had once experienced powerful volcanic activity. Other rocks showed signs of enormous impacts that had shaped the lunar surface over unimaginable spans of time. Later missions continued expanding our knowledge. One of the final and most scientifically productive missions was Apollo 17. During this mission, astronauts spent several days exploring the moon's surface, collecting more than 100 kilograms of rock and soil samples. These samples would later help scientists understand not only the moon, but also the early history of Earth itself. But even as these discoveries were being made, something unusual was happening back on Earth. Public excitement about the moon landings was beginning to fade. When humans first walked on the moon, it felt like the greatest adventure in history. Newspapers around the world filled their front pages with stories about space exploration. Television broadcasts were watched by hundreds of millions of people. But after several missions, the experience began to feel less new. Another rocket launch, another landing, another group of astronauts collecting rocks on a distant world. For scientists, each mission was incredibly valuable. But for many people watching from Earth, the sense of wonder slowly began to fade. At the same time, the Apollo program was extremely expensive. Landing humans on the moon required enormous rockets, complex spacecraft, thousands of engineers, and years of preparation for each mission. The total cost of the Apollo program eventually reached around $25 billion in 1970s money. Adjusted for modern values, that would equal well over $150 billion today. Governments began asking difficult questions. Was it worth spending so much money on lunar missions when there were many other problems on Earth that needed attention? The early 1970s were also a time of political change and economic challenges in the United States. Priorities began shifting. Instead of focusing entirely on the moon, NASA was encouraged to develop new kinds of space missions. Some leaders believed that building reusable spacecraft, such as space shuttles, would allow more frequent and affordable travel to orbit around Earth. As a result, several future Apollo missions were quietly cancelled. Missions that had already been planned, such as Apollo 18, Apollo 19, and Apollo 20, would never fly. When Apollo 17 returned safely to Earth in December of 1972, it marked the end of an extraordinary chapter in human history. For the first time since 1969, no new moon missions were scheduled. Astronauts had walked on another world. They had driven across its dusty valleys and climbed its ancient hills. They had collected rocks that were billions of years old. And then suddenly, humanity stopped going. 4 decades afterward, the moon remained quiet and untouched by human footsteps. Only robotic spacecraft continued to visit from time to time, silently orbiting or landing on the surface to conduct scientific research. Many people began to wonder whether humans would ever return. But the story of why we stayed away from the moon for so long is not only about money or politics. There were also technological challenges, shifting goals in space exploration, and even new discoveries that changed how scientists thought about exploring the solar system. And as the years passed, something interesting began to happen. The dream of returning to the moon slowly started to grow again. But this time, the plan would be very different from the missions of the 1960s. Instead of short visits lasting only a few days, scientists began imagining something much more ambitious: permanent bases, astronauts living and working on the moon for months at a time, new spacecraft designed for long journeys deeper into space. Because in many ways, the moon may not be the final destination. It might simply be the first stepping stone towards something even greater: the exploration of Mars, and perhaps one day, the exploration of the entire solar system. For many years after the final mission of Apollo 17, the moon remained silent. No human spacecraft returned. No astronauts walked across its dusty plains. The footprints left behind during the Apollo missions remained exactly where they were, preserved in the stillness of the lunar surface. Unlike Earth, the moon has no wind, no rain, and no flowing water that could erase those marks. The tracks left by the astronauts, the landing sites, and even the wheel marks from the lunar rover may remain visible for millions of years. But while humans stopped traveling to the moon, space exploration itself did not stop. Instead, the focus of many space programs slowly began to change. Rather than sending astronauts to nearby destinations, scientists began launching robotic spacecraft to explore the far reaches of the solar system. These machines could travel much farther than human crews and operate for years without needing food, oxygen, or protection from radiation. In the late 1970s, NASA launched 2 spacecraft that would become some of the most famous explorers ever built: Voyager 1 and Voyager 2. These spacecraft traveled billions of kilometers through space, visiting giant planets and sending back incredible images and data. They revealed active volcanoes on Jupiter's moon Io, massive storms on Saturn, and strange icy worlds orbiting the distant outer planets. For scientists, these discoveries were incredibly exciting. Entire new worlds were being revealed, places that humans had never seen before. At the same time, NASA was developing a new type of spacecraft that could travel repeatedly between Earth and orbit. This project became known as the Space Shuttle program. The idea behind the Space Shuttle was very different from the Apollo missions. Instead of building a new rocket for every flight, the shuttle could be launched, land like an airplane, and then be prepared for another mission. Beginning in 1981, the shuttle carried astronauts into orbit dozens of times. Crews repaired satellites, performed scientific experiments, and helped build one of humanity's most ambitious engineering projects in space. That project became the International Space Station. Orbiting about 400 kilometers above Earth, the station became a permanent laboratory in space where astronauts from many countries could live and work for months at a time. The focus of human spaceflight had shifted. Instead of traveling far away to the moon, astronauts were now learning how to live in space for long periods of time. This research turned out to be extremely important. Living in space presents many challenges for the human body. Without gravity, muscles gradually weaken and bones lose density. Fluids in the body shift toward the head, affecting vision and circulation. By studying these effects aboard the International Space Station, scientists began learning how humans might survive much longer journeys through space. And slowly, the idea of returning to the moon began to appear again. But this time, it would not simply be about repeating the achievements of the Apollo era. Instead, the moon was beginning to look like something much more valuable, a testing ground for future exploration. Scientists realized that the moon could serve as a kind of stepping stone deeper into the solar system. Its gravity is much weaker than Earth's, which means rockets launched from the lunar surface would require far less fuel to travel into deep space. In addition, new discoveries suggested that the moon might contain important resources. For many years, scientists believed the moon was completely dry, but in the early 2000s, several spacecraft began detecting signs that water might exist in permanently shadowed craters near the lunar poles. One mission that helped confirm this possibility was Lunar Reconnaissance Orbiter. The data from the spacecraft suggested that frozen water ice might exist deep inside dark craters that never receive sunlight. This discovery changed the way scientists thought about the moon. Water is incredibly valuable in space. It can be used for drinking, for growing plants, and even for producing rocket fuel by separating it into hydrogen and oxygen. If astronauts could access ice on the moon, they might be able to create a permanent presence there without needing to bring every resource from Earth. And so, after decades of silence, plans for returning humans to the moon began to grow stronger. One of the most ambitious modern projects is the Artemis program. Named after the sister of the ancient Greek god Apollo, this program represents a new generation of lunar exploration. The goal is not just to visit the moon for a few days. The goal is to stay. Future missions may build research bases near the lunar South Pole, where ice deposits appear to be most accessible. Astronauts may live there for months, studying the moon's geology, testing new technologies, and preparing for even longer journeys. Because in the long term, the moon may become a training ground for humanity's next great destination, Mars. Reaching Mars will be far more difficult than traveling to the moon. The journey could take many months, and astronauts would need to survive in deep space for long periods without the possibility of immediate rescue. Before such missions become possible, scientists need to learn how humans can live and work on other worlds. The moon, only a few days away from Earth, provides the perfect place to begin that journey. And so the long absence of humans on the moon may not have been an abandonment at all. Instead, it may have been a pause, a quiet moment in history while humanity prepared for the next chapter of exploration. Because the story of the moon is not finished. In fact, it may be just beginning. Long ago, when humans first looked up at the night sky, the moon seemed like the most mysterious object in the universe. It was close enough to see clearly, yet impossibly far away. For thousands of years, people imagined gods living there, ancient civilizations, or hidden worlds on its surface. But by the middle of the 20th century, humanity had finally developed the technology to reach it. The story of how we arrived at the moon is dramatic and exciting, but the story of why we stopped going there is even more mysterious. During the 1960s, the world was in the middle of an intense technological and political competition known as the space race. Two superpowers, the United States and the Soviet Union, were pushing the limits of science in an effort to prove which system was more advanced. In 1961, the Soviet Union shocked the world when Yuri Gagarin became the first human to travel into space. For the United States, this was a wake-up call. The response came from John F. Kennedy, who made a bold promise. America would land a man on the moon before the end of the decade. To accomplish this goal, the United States launched the massive Apollo program. At its peak, the program employed over 400,000 engineers, scientists, and workers. Entire cities of factories were built to design rockets, computers, navigation systems, and life support technologies. The rocket that would carry astronauts to the moon was the gigantic Saturn V rocket, the most powerful launch vehicle ever successfully flown. Standing 110 meters tall and producing more thrust than any machine before it, it was essentially a controlled explosion powerful enough to escape Earth's gravity. Finally, in July of 1969, the mission known as Apollo 11 launched from Florida. Inside the spacecraft were 3 astronauts: Neil Armstrong, Buzz Aldrin, and Michael Collins. After traveling nearly 384,000 kilometers through space, the lunar module separated from the main spacecraft and slowly descended toward the dusty gray surface of the moon. When Neil Armstrong stepped out onto the lunar surface, he spoke the famous words that would become one of the most recognizable quotes in human history. "One small step for man, one giant leap for mankind." For the first time ever, a human being was standing on another world. But what many people forget is that this was not the only moon landing. Between 1969 and 1972, NASA successfully sent 6 different missions to the moon. Astronauts drove lunar rovers across the surface, collected rocks, conducted experiments, and explored areas never seen before by human eyes. Missions like Apollo 12, Apollo 14, Apollo 15, Apollo 16, and Apollo 17 expanded humanity's understanding of the moon dramatically. Astronauts brought back nearly 400 kilograms of lunar rock samples. These rocks revealed that the moon formed billions of years ago, most likely after a gigantic collision between the early Earth and a Mars-sized object. From a scientific perspective, the moon missions were a massive success. And yet, something strange happened. After December of 1972, when the crew of Apollo 17 returned to Earth, humans never went back. For more than half a century, not a single astronaut has walked on the moon again. This is one of the most puzzling questions in the history of space exploration. Why did humanity stop going to the moon? At first glance, the answer seems simple: money. The Apollo program was incredibly expensive. When adjusted for modern inflation, it cost over $250 billion. At the height of the program, NASA's budget consumed about 4% of the entire federal budget of the United States. Once the main political goal of beating the Soviet Union had been achieved, the urgency disappeared. Public attention shifted toward other problems happening on Earth. The early 1970s were a time of economic pressure, political tension, and global change. Governments began asking an uncomfortable question: was it worth spending billions of dollars just to visit the moon again? As a result, several planned Apollo missions, including Apollo 18, Apollo 19, and Apollo 20, were cancelled before they ever launched. The Saturn V rockets that had been built for those missions were never used for lunar travel. Some were placed in museums. Others were repurposed for different space projects. But money alone may not explain everything. Another factor was risk. Space travel is extremely dangerous. During the mission Apollo 13 in 1970, an oxygen tank exploded during the journey to the moon. The astronauts barely survived, and the mission had to be aborted. The world watched in suspense as NASA engineers struggled to bring the crew safely back to Earth. It was a reminder that even the most advanced technology could fail in the harsh environment of space. Each launch carried enormous risk, and every mission required thousands of people working perfectly together. Eventually, NASA began shifting its focus toward a different strategy. Instead of traveling to the moon repeatedly, scientists wanted to develop reusable spacecraft that could operate closer to Earth for longer periods of time. This led to the creation of the Space Shuttle program. The idea behind the Space Shuttle was revolutionary. Unlike the Apollo capsules, which were used once and then discarded, the shuttle could land like an airplane and be flown again. The first shuttle mission launched in 1981 aboard Space Shuttle Columbia. For the next 3 decades, space shuttles carried astronauts into orbit, launched satellites, and helped build one of the most ambitious engineering projects ever attempted in space, the International Space Station. But even though humans continued exploring space, the moon remained untouched. Year after year, decade after decade, the distance between Earth and the moon stayed the same, but humans stopped crossing it. Some people began asking deeper questions. Was the moon really as simple as we thought? Or was there something about it that made governments lose interest so quickly? While the official explanations focused on budgets and priorities, the mystery of the 50-year absence from the moon continues to fascinate millions of people around the world. And now, in the 21st century, humanity is preparing to return once again. Through the new Artemis program, NASA and its international partners plan to send astronauts back to the lunar surface, this time with the goal of building a permanent presence. But as we prepare to go back, the question still lingers quietly in the background. If the moon was such a historic achievement in the 1960s, why did we stay away for so long? And what might we discover when humans finally set foot there again? As humanity prepares to return to the moon in the coming years, many people are beginning to realize something surprising. The moon is no longer just a destination for a historic flag and footprints. It may actually become one of the most important places for the future of human civilization. But to understand why the moon matters so much today, we first need to understand what scientists discovered during those early missions in the 1960s and 1970s. When astronauts from the Apollo program explored the lunar surface, they didn't just plant flags and take photographs. They conducted dozens of experiments designed to answer fundamental questions about the origin of the moon, the history of our solar system, and the conditions that might exist on other worlds. One of the most important discoveries came from a lunar rock samples brought back to Earth. By analyzing these rocks, scientists concluded that the moon most likely formed around 4.5 billion years ago after a massive cosmic collision. According to the widely accepted giant impact hypothesis, a Mars-sized object slammed into the early Earth. The debris from this collision eventually gathered together and formed the moon. This violent origin explains many of the moon's unusual characteristics. For example, the moon has very little iron compared to Earth, suggesting that most of the heavy elements remained on our planet after the collision. The moon also has almost no atmosphere, meaning that its surface has remained largely unchanged for billions of years. This makes the moon something like a time capsule of the early solar system. Every crater, every rock, every layer of dust tells a story about ancient cosmic events. But even with these discoveries, scientists quickly realized that exploring the moon was much harder than it appeared in movies or science fiction. Temperatures on the lunar surface can swing from around plus 120 C during the day to -170 C at night. Without an atmosphere to regulate heat, the environment is extremely harsh. There is also no air to breathe, no liquid water on the surface, and almost no protection from cosmic radiation or micrometeorites. For astronauts staying on the moon for only a few hours, these dangers were manageable. But building a permanent base would require completely new technologies. For decades, those technologies simply didn't exist. That is one reason why the moon remained silent after the final mission, Apollo 17, left in 1972. Meanwhile, NASA shifted its focus toward missions closer to Earth. The development of the Space Shuttle program allowed astronauts to travel to orbit regularly. This eventually made it possible to assemble the International Space Station, a massive laboratory floating about 400 kilometers above Earth. For more than 2 decades, astronauts from many different countries have lived and worked aboard the station, studying everything from microgravity physics to human biology in space. But during all those years, the moon continued to wait quietly in the distance. Then, something changed. In the early 2000s, scientists began discovering something unexpected in lunar data. There might be water on the moon. At first, this idea sounded almost impossible. The moon has no rivers, no oceans, and no clouds. For most of the 20th century, scientists believed it was completely dry. But spacecraft observations told a different story. In 2009, a mission called Lunar Crater Observation and Sensing Satellite, often shortened to ICROSS, deliberately crashed a probe into a permanently shadowed crater near the moon's south pole. When the impact sent dust and ice into space, instruments detected clear signs of frozen water. This discovery changed everything. If water exists on the moon, it could potentially be used to support astronauts. Water can be turned into drinking supplies, breathable oxygen, and even rocket fuel by splitting it into hydrogen and oxygen. Suddenly, the moon was no longer just a scientific destination. It became a potential resource. This is one of the key reasons why modern space agencies are preparing to return. Through the Artemis program, NASA plans to land astronauts near the moon's south pole later this decade. The mission architecture includes a powerful new rocket called the Space Launch System and a crew spacecraft known as Orion spacecraft. Unlike the Apollo missions, which were short visits, Artemis is designed to build a long-term presence. The plan includes constructing a small space station orbiting the moon called the Lunar Gateway. This station will act as a staging point for missions to the surface and eventually for journeys deeper into space. And that brings us to one of the most fascinating ideas in modern space exploration. The moon may become humanity's launchpad for Mars. Because the moon's gravity is much weaker than Earth's, launching rockets from its surface requires far less fuel. If resources like water ice can be mined there, future spacecraft might be assembled and fueled directly on the moon. In other words, the moon could become the first step toward becoming an interplanetary species. But even now, more than 50 years after the last Apollo astronaut left the lunar surface, many mysteries about the moon remain unsolved. Some of the deepest craters near the poles have never been explored by humans. Certain regions of the far side of the moon have never been visited at all. And scientists still debate how the moon's interior is structured, how its magnetic field disappeared billions of years ago, and how its surface evolved over time. The moon may look quiet and familiar when we see it shining in the night sky, but in reality, it is still a largely unexplored world. And soon, for the first time in half a century, humans may finally return. When that moment happens, the next chapter of lunar exploration will begin, not as a short race between rival nations, but as a long journey that could shape the future of humanity in space. But there is still one question that remains. If the moon holds so many secrets and so many possibilities, what else might be waiting there, hidden beneath billions of years of untouched lunar dust? For most of human history, the moon was simply a light in the sky. Ancient civilizations used it to measure time, guide agriculture, and navigate across oceans. Poets wrote about it, philosophers wondered about it, and early astronomers studied its changing phases with primitive telescopes. But no one imagined that one day humans would walk there. When astronauts from the Apollo program finally stepped onto the lunar surface, the moon changed forever in the human imagination. It was no longer just a distant object in the night sky. It became a real place, a world that people could visit. And yet, despite this incredible achievement, our exploration of the moon was incredibly brief. If you think about it, humans have spent more time living continuously on the International Space Station than they have spent walking on the moon. In total, all the astronauts combined to explore the lunar surface during the Apollo mission spent only about 80 hours outside their spacecraft. That is barely more than 3 days. 3 days of exploration on an entire world. To put that into perspective, the moon's surface area is about 38 million square kilometers, roughly the size of Africa. Almost all of that remains completely unexplored. Even today, the places where astronauts once walked remain some of the most studied locations in space science. The landing sites of missions like Apollo 11, Apollo 15, and Apollo 17 are still visible in satellite images taken by modern lunar orbiters. You can even see the faint tracks left behind by lunar rovers. These tracks may remain visible for millions of years because the moon has no atmosphere, no wind, and almost no geological activity. It is a frozen landscape where footprints can survive almost indefinitely. But this quiet surface hides a surprisingly complex history. For billions of years, the moon has been bombarded by asteroids and comets. Each impact carved massive craters into its surface. Some of these craters are so large they can be seen with the naked eye from Earth. One of the most dramatic examples is the enormous South Pole Aitken Basin on the far side of the moon. This impact basin is nearly 2,500 kilometers wide, making it one of the largest known craters in the entire solar system. Scientists believe the impact that created it happened more than 4 billion years ago, during a chaotic time known as the Late Heavy Bombardment. During this period, countless asteroids and debris left over from planet formation were crashing into the inner planets. Earth was hit constantly. Mars was hit, and the moon was hit even more. But unlike Earth, where erosion, weather, and tectonic activity erase ancient scars, the moon preserved this violent history in remarkable detail. In a way, the moon is like a museum of the early solar system. Every crater tells a story about a collision that happened billions of years ago. And yet, the moon is not completely inactive. For a long time, scientists believed that the moon was geologically dead, a world that had cooled and stopped evolving billions of years ago. But newer observations suggest something more complicated. High-resolution data from orbiting spacecraft, including missions like Lunar Reconnaissance Orbiter, have revealed small cliffs and fractures on the lunar surface called lobate scarps. These features appear to have formed relatively recently in geological terms. Some scientists believe there may be evidence that the moon is slowly shrinking. As the moon's interior cools, it contracts slightly, causing the crust to wrinkle and crack in certain regions. Over millions of years, these movements can create small moonquakes. Yes, the moon can have earthquakes. They are called moonquakes, and they were first detected during the Apollo missions when astronauts placed seismometers on the surface. Some of these moonquakes lasted for more than 10 minutes, far longer than most earthquakes on Earth. This happens because the moon has very little water in its rocks. Without water to dampen vibrations, seismic waves can bounce around inside the moon for much longer periods. In other words, when the moon shakes, it rings like a giant bell. All of these discoveries remind us of something important. Even though the moon looks quiet and familiar when we see it rising above the horizon, it is still a mysterious world. And now, after more than 50 years, a new generation of spacecraft and astronauts is preparing to explore it again. Through the Artemis program, scientists hope to answer questions that were impossible to study during the short Apollo visits. They want to explore the permanently shadowed craters near the lunar poles, where sunlight has not reached for billions of years. These craters may contain ancient ice deposits, frozen records of the solar system's past. They want to build long-term habitats that could allow astronauts to live and work on the moon for months instead of days. And perhaps most importantly, They want to learn how humans can survive on another world, because the lessons learned on the moon may one day help us reach even more distant places, Mars, asteroids, and maybe one day worlds beyond our solar system. But before any of that happens, humanity must return to the moon, the same moon that has been watching over Earth for billions of years, the same moon that inspired myths, legends, and scientific curiosity across countless generations. And when humans finally walk there again, the next chapter of exploration may begin, not just as a historic achievement, but as the first step toward a much larger future among the stars. And perhaps the most fascinating part of this story is that the moon has been there the entire time waiting, and as we look at the moon today, hanging quietly in the night sky, it's easy to forget just how unusual it actually is. Among all the planets in our solar system, Earth's moon is something special. Most planets either have no moons at all or have many small ones. For example, Mars has 2 tiny moons, Phobos and Deimos, both of which are irregularly shaped and likely captured asteroids. Meanwhile, giant planets like Jupiter and Saturn have dozens of moons, many of them small and distant. But Earth's moon is different. It is unusually large compared to its parent planet. In fact, the moon's diameter is about 1/4 the size of Earth, which makes it one of the largest moons relative to its planet anywhere in the solar system. Because of this, the Earth-Moon system behaves almost like a double planet. The moon's gravity has played an enormous role in shaping the history of Earth. One of the most important effects is the creation of ocean tides. The gravitational pull of the moon constantly stretches Earth's oceans, producing the familiar rise and fall of sea levels along coastlines. But tides are not just an ocean phenomenon. They also occur in the Earth's crust and even in the atmosphere. Over millions of years, these tidal forces have had a surprising effect. They are slowly slowing down the rotation of our planet. Billions of years ago, a day on Earth was much shorter, possibly only 6 to 8 hours long. But as the moon's gravity gradually drained rotational energy from Earth, the length of a day increased. Today, the average day lasts 24 hours, and the process is still continuing. Each year, the moon moves about 3.8 centimeters farther away from Earth. This tiny distance may not seem like much, but over millions of years it adds up. Hundreds of millions of years in the future, the moon will appear noticeably smaller in our sky. But in the distant past, the moon looked dramatically larger. Imagine standing on the early Earth billions of years ago and looking up at a moon that filled much more of the sky than it does today. It would have been an incredible sight. The moon also helps stabilize Earth's axial tilt, the angle at which our planet spins relative to its orbit around the sun. Without the moon, Earth's tilt might vary periodically over time, similar to what scientists believe happens on Mars. Large variations in axial tilt could create extreme climate shifts, potentially making Earth far less stable for life. In this way, the moon may have quietly helped create the stable environment that allowed complex life to evolve. It is possible that without the moon, the history of life on Earth might have unfolded very differently. But the moon's influence does not end there. It has also shaped human culture in profound ways. Ancient calendars were based on lunar cycles. The word month itself comes from the moon. Festivals, rituals, and myths across countless civilizations were tied to the changing phases of the moon. Even today, many holidays and traditions are determined by lunar calendars. For thousands of years, the moon guided farmers, navigators, and astronomers. And eventually, it guided scientists and engineers who dreamed of traveling there. When the astronauts of Apollo 11 first set foot on the lunar surface, they were continuing a journey of curiosity that had begun thousands of years earlier. Yet despite that historic achievement, the moon has remained largely untouched since the final Apollo mission. For more than half a century, robotic spacecraft have continued exploring it from orbit. Missions like Lunar Reconnaissance Orbiter have mapped the lunar surface in incredible detail, revealing mountains, lava plains, deep craters, and mysterious geological formations. Other countries have also begun sending missions. For example, the China National Space Administration has successfully landed multiple robotic explorers through its Chang'e program. One of these missions, Chang'e 4, made history in 2019 by landing on the far side of the moon, the hemisphere that always faces away from Earth. This region had never been explored directly before. Meanwhile, other nations including India, Japan, and the European Space Agency are also planning future lunar missions. In other words, a new era of lunar exploration is beginning. But this time, the goal is very different from the original space race. Instead of a short competition to prove technological superiority, the modern vision of the moon involves long-term exploration and cooperation. Scientists are imagining research bases near the lunar poles, mining operations that could extract water ice from shadowed craters, telescopes on the far side of the moon that could observe the universe without interference from Earth's radio signals, and perhaps someday, cities beneath protective domes. It sounds like science fiction today, but so did landing on the moon once. The difference now is that technology has advanced dramatically since the 1960s. New rockets, advanced robotics, artificial intelligence, and improved life support systems are making it possible to attempt missions that would have been impossible during the Apollo era. And slowly, step by step, humanity is preparing to return. When the first astronauts of the new generation land on the moon again through the Artemis program, they will not simply be repeating history. They will be opening the door to a much larger future. A future where the moon becomes humanity's first outpost beyond Earth. A future where the night sky is no longer just something we observe but something we explored. But before humans build bases on the moon, before rockets regularly travel between Earth and lunar orbit, there is another important question scientists must answer. Can humans actually live there for long periods of time? The Apollo missions were short. Astronauts spent only a few days on the lunar surface before returning home. That was manageable. But living on the moon for weeks, months, or even years is a completely different challenge. The first major problem is radiation. On Earth, we are protected by two powerful natural shields: our planet's atmosphere and its magnetic field. These layers block most of the harmful radiation coming from the sun and deep space. But the moon has neither. Without an atmosphere and without a global magnetic field, the lunar surface is constantly exposed to cosmic radiation and energetic particles from solar storms. Over time, this radiation can damage human cells and increase the risk of cancer and other health problems. This means that future lunar habitats will likely need to be built underground or covered with thick layers of lunar soil, known as regolith, to protect astronauts. Interestingly, scientists believe the moon may already contain natural underground spaces that could help solve this problem. Some researchers think there are enormous lava tubes beneath the lunar surface. These tunnels formed billions of years ago when molten lava flowed beneath the crust and later cooled, leaving empty passages behind. On Earth, lava tubes can be only a few meters wide. But because the moon has much weaker gravity, lunar lava tubes could be hundreds of meters wide and several kilometers long. Imagine an underground cavern large enough to fit an entire city. These natural structures might one day serve as protected habitats for astronauts. The second major challenge is temperature. A single day on the moon lasts about 29.5 Earth days. That means lunar nights last roughly 2 weeks. During the long lunar day, sunlight can heat the surface to around 120 C. But during the long night, temperatures can drop to 170 C. These extreme temperature swings are far more severe than anything humans experience on Earth. Future lunar bases will need advanced insulation systems, energy storage technology, and reliable power sources. One possible solution is nuclear power. NASA and other space agencies are studying small, portable nuclear reactors that could provide continuous energy during the long lunar night. Another challenge is lunar dust. The dust on the moon is very different from the dust on Earth. Because there is no wind or water to smooth the particles, lunar dust grains are extremely sharp and jagged. During the Apollo missions, astronauts discovered that the dust stuck to their suits, equipment, and spacecraft. It behaved almost like powdered glass. If inhaled or allowed to accumulate inside habitats, this dust could become a serious health hazard. Future missions will need advanced airlocks, dust filters, and protective materials to manage this problem. And then there is the challenge of low gravity. The moon's gravity is only about 1/6 of Earth's gravity. Astronauts during the Apollo missions enjoyed hopping across the surface in slow motion jumps. But scientists still don't know what would happen if humans lived in such low gravity for years. Long-term exposure could weaken bones and muscles, similar to what astronauts experience aboard the International Space Station. Understanding how the human body adapts to lunar gravity will be one of the most important experiments of future missions. Despite all these challenges, the moon offers one enormous advantage. It is close. In cosmic terms, the moon is practically next door. The average distance between Earth and the moon is about 384,000 kilometers, which means spacecraft can travel between them in just a few days. Compare that to Mars, which can be tens of millions of kilometers away depending on its position in orbit. A mission to Mars can take 6 to 9 months. If something goes wrong on the moon, astronauts could potentially return to Earth relatively quickly. Because of this, many scientists see the moon as a training ground for deep space exploration. Before humanity attempts missions to Mars or beyond, we must learn how to live and work on another world. The moon is the perfect place to practice. But perhaps the most exciting possibility is that the moon could become more than just a research station. Some experts believe it could become the first permanent human settlement beyond Earth. Imagine a future where astronauts, scientists, engineers, and explorers live on the moon for years at a time. They might build research laboratories, mining facilities, communication stations, and even observatories. The far side of the moon, shielded from Earth's radio noise, could become the ideal location for giant radio telescopes studying the deepest parts of the universe. These telescopes might detect signals from the earliest galaxies or even search for signs of extraterrestrial civilizations. All of this may sound like science fiction today. But remember, just 100 years ago, powered flight itself was still new. And only 60 years ago, humans had never traveled beyond Earth orbit. Then suddenly, in 1969, astronauts from the Apollo 11 stood on the surface of another world. History shows that human progress can sometimes move very slowly and then suddenly leap forward. Now, as the Artemis program prepares to send astronauts back to the moon, the long silence of the lunar surface may finally come to an end. For 50 years, the moon has waited. Soon, human footprints may once again appear in its ancient dust. And this time we might not leave.